Good evening. Scott Small here from Ripley, Oklahoma. I'm taking Professor Norman's AT 722 class this semester, the Alternative Fuels in Transportation. So today's project I'm going to be talking about portable generators, and mainly a dual fuel unit that is run on both propane and gasoline. Now traditionally generators are mainly gasoline fired units, but recently over the last, 3, 4, or 5 years, you're starting to see more and more dual fuel units pop up out there. So I recently purchased one just for emergency power at the house, and it worked well with this class and with this project. So, why propane? Well, it's not Hank Hill, propane and propane accessories, but I thought maybe you'd need a little laugh tonight. So, readily available, propane, you can find it, at least for the 20-pound cylinder exchanges that you would use on a propane-fired generator. You can find them anywhere, Dollar General, Casey's gas stations, Dillon's, Walmart. I mean, the list goes on and on and on. So, they're pretty easy to find and pretty easy to swap out. Proven fuel source, put this in there because there's been internal combustion engines running on propane for decades and decades. From the automotive side all the way down to small internal combustion units. Ease of use, we're going to dig into this just a little bit, mainly on the switching back and forth from gasoline to propane, how that actually works. I've got a video to demonstrate that. Also ease of use of just propane. It's a thread-on connector, open a valve, and off you go. So there's not a lot to propane beyond what you're already doing with gasoline. You still have to handle it, safely. So cost, there's a couple ways to look at this. We'll go automotive first. So I pulled this off the Alternative Fuels Data Center. So January 1st through January 20th, the average gasoline price in the United States was $2.59, and the average propane cost was $2.79 per gallon. So it's pretty comparable when you're doing the cylinder swaps. They're slightly more expensive just because you're dealing in smaller quantities, but very, very price competitive with gasoline. Fuel economy. Now I put an asterisk next to this because this is really the main feature of my project. I chose a metric that I don't know if anybody ever has before, but the calculation made sense to me, and it was a good way to compare the generator running on two different fuels. So what I chose to do was fuel burned per minute, and that's pounds of fuel burned per minute is the unit that I chose to use. So the generator that I'm using is a 3,500 watt Champion, commonly available. I found them at Walmart.com for $429. My unit was purchased at Cabela's right after the first of the year on sale for $399. So this is not an expensive unit. It's easily affordable for most people that are looking for an emergency power solution, or a solution for an RV or boondocking, perhaps a hunting cabin where you need remote power. So it's a good unit. It's got a 2.5 gallon fuel tank, which will come into play here after a while. Okay, so earlier we mentioned ease of use, and what I'm going to demonstrate in this video, and I'm going to narrate it, so it may be just a little bit clunky here at first, but we're going to show how to go from gasoline to propane on this unit. So the first thing is you've got your cylinder on the left-hand side. And you'll see my hand reach down in a minute. We're going to open up that valve. So that is the first step with the engine off to starting this unit on propane. So once the valve's open, the propane is free to flow with the included hose. And now we're going to turn the fuel off with this fuel pack on. Once the fuel's turned off, there's a physical cover that slides over. And now you've got your onboard propane hand valve. So you got to open that up to get propane to the unit. Just like any generator, you've got a master on and off switch. Make sure that's on. Now this unit is ready to fire up. Now this is a pull start unit. Some higher dollar units are electric start. This one's pull start, but it is ready to go at this point. Okay, so for my generator test, my like load is a combination of these pictures. We're going to compare 1 pound of propane versus 1 pound of gasoline. Using the load of my camper down there in the left-hand corner in the air conditioner. That's a 13,500 BTU air conditioner unit. We're going to let it run continuous with the doors open so it does not catch up and cycle off, right? What we'll also do is we'll brew 2 single cups of coffee on the 1 pound test. Now, on the 1 gallon test, we're going to have to put a higher load on this unit, so that's where the toaster oven comes into play, and we'll be doing 4 10-minute runs, so 40 total minutes that toaster oven will be running when we do our 1 gallon test. This provides a little additional load, and as you'll see, this generator can run a long time on 1 gallon, so just for the sake of speed, we needed to put more load when we do our 1 gallon test. So, gasoline, our 1 pound test run. Carburetor needs to be filled up. Prior to doing this run, I made that mistake my first time around, poured in 1 pound of fuel, and I didn't run very long. I think it was about 10 minutes. So I assumed a 1 gallon run, which is 6 pounds, would go about 60 minutes. Easy math, right? However, that was wrong. I kept running and running and running. So I decided to start over and revalidate my 1 pound test run by filling the carburetor first. This yielded me 34 minutes of runtime with that test load, which is the 2 cups of coffee and the 13,500 BTU unit running constant. You can see my scale down there on the left-hand side. Yes, I did take into account via tare weight with the gas can before I weighed the fuel out. Just know that I use this scale throughout to check weights. So the propane 1 pound test run, a lot more interesting on the propane side because you got to actually physically watch the scale count down from 32.2 pounds to 31.2 pounds for your 1 pound test. Same load, 2 cups of coffee, the air conditioner running on constant, and this yielded us 31 minutes. So if you remember, gasoline was 34, this one's 31. So a little bit less, but still pretty comparable, not very far off. I thought there'd be a bigger difference. Moving into the 1 gallon test run, this is where I think the most accurate data comes from. So the carburetor needs to be filled. You can see my test load is now increased to include those 4 toaster oven runs, and actually did include 3 microwave runs as well. So my total run time is 3 hours and 54 minutes. That's a long time to sit there and drink coffee. 234 total minutes. The math on that comes out to 39 minutes per pound of fuel burned. So we'll come back to that 39 number here in a little bit for comparison to propane, but just start thinking about that as we move through the propane slides. So propane, here's your 1 gallon test run. I've got a quick little video here, similar to the last one, except for I'm going to let the narration be in the video.
Okay, got the 2nd cup of coffee brewing on the propane test. We started at 32.2 pounds, we're down to 31.6. So we've done the heat checks, starting to watch the scale to make sure we get that right. We're doing the carbon monoxide checks next.
Okay, so you got to see the generator running and finishing up a cup of coffee there. You can also see my scale where I started with 31.2 pounds and ran it down to 27 pounds. So that's 4.2 pounds of fuel consumed for 1 gallon. Quite interesting, the results of that, and we'll get to that in the next slide. So here we have a blown up version of my whiteboard. I wanted to pull up the real version. I chose to go old school instead of using a spreadsheet. So we've got a pile of data on here. It's not important to actually read it. I just wanted to show if you're going to do this test, you can draw quite a bit of data from your scale readings, and I do suggest probably using a program like Excel versus doing it on a whiteboard. However, I had the whiteboard there, and I was sitting there drinking coffee for minutes and minutes and minutes, so that's what I did. Okay, so you can see the total runtime with that constant load was 2 hours and 48 minutes, so 168 total minutes. So the fuel economy on the propane is 40 minutes per pound of fuel burned. So we got a little bit better fuel economy out of the propane when we went to the higher load and longer sustained load operation. Now, the video that I just showed a minute ago, it introduced our final 2 tests that we're going to look at. So exhaust temperature. Exhaust temperature can be more important for a slimline dual fuel unit that's maybe mounted on the underbelly of an RV. You're looking to keep any heat load off that unit. They're usually not that well insulated, so the more you can help your air conditioners out, the better. Took these readings from about 2 inches away with an infrared temp gun. Probably not an exact science to get the number, but what I'm mainly concerned with is the delta between the two. So you can see our average, 5 readings, take an average, pretty simple. 326 degrees on the propane and 307 degrees on the gasoline. So the propane burns a little hotter, so that may affect your decision, or may affect what kind of generator you want to buy, like an underbelly mounted one, or one that you would roll around outside like mine that I showed earlier. So carbon monoxide output. So why is CO important? So carbon monoxide is a silent killer. You can't smell it. You don't know when it's hit you. A lot of these small generators are used in camping situations. So sleeping in your camper, you get exhaust fumes in there. It can be deadly. It can be fatal. However, most RVs are equipped with a carbon monoxide tester. So RVing is not such a big deal, but boondocking, maybe a hunting cabin, we're using this for remote power. If you've got it up close to your cabin or house, it's very important to keep these things well ventilated. Same kind of thing. Took 5 readings of each. I made a homemade, I'm going to call it a wooden chute, 18 inches long, which kept it spaced away from the exhaust, 18 inches, but it did direct the exhaust flow directly on the inlet port of the handheld tester. So again, I would need a gas analyzer, like a 5-gas analyzer, to really look at the exhaust gases, but I'm going for the delta here, just looking at a difference between the two fuels. And what I found was quite a bit. So we've got 596 parts per million, 600 for propane, and 802 parts per million for gasoline. So the propane did burn a little hotter, if you remember the last slide. However, it burned a little cleaner when you're talking about carbon monoxide. So in my opinion, and the way I would look at it is propane would be a better choice if you're using those two categories, just due to the fact that you have less carbon monoxide. Carbon monoxide is very dangerous. That's why I included it in this test. So here's kind of the compilation slide of the last several that we've been talking about, and the first bullet point goes right back into where we started. 40 minutes per pound of fuel burned, and then 39 minutes per pound of fuel burned. So gasoline, you're going to go through it a little quicker. However, it is cheaper at the pump. It is cheaper to purchase. CO output, we talked about how dangerous that can be for RVs. So that could be a major decision maker for you if you're choosing to purchase a propane versus a gas. Exhaust temperatures, it's pretty close there, right? 326 to 307. So we'll call that a tie. One of the biggest things I think is onboard fuel. So 2.5 pound gas tank on this thing, which is 15 pounds of fuel. It'll get you, with this load, 585 minutes, versus propane on a 20-pound cylinder. If they're filled correctly, they'll have 19.74 pounds of actual fuel in that cylinder. That can yield you 789 minutes under this load that we tested. So for me, I don't like to get up at 3 o'clock in the morning and refill the gasoline on a generator. So that bottom bullet point outweighs a lot of the other bullet points for me when it comes time to a portable generator. So that's what we've got. Please provide any comments, feedback in the here on YouTube, or log into Canvas and provide them there. I appreciate your time and look forward to watching a couple other videos from the class. Thank you.